and thank you for joining us today for an exciting panel discussion with Nil Technology, Fabulous, Epic and Zemax. My name is Kerry Herbert and I'm the European Marketing Manager at Zemax. I would like to start off with a little bit of housekeeping before we get going. You will notice at the bottom of your console a menu of engagement tools. If you have any questions for our panellists, please utilise the Q&A box to submit your inquiries. We will try to respond to your questions through the discussion as time permits. Also, feel free to check out the speaker biographies and share your comments on the discussion in the group chat window. We would also like to hear from you, so please fill out the webinar survey to help us improve our content in the future. Last but not least, if you are experiencing technical difficulties, click on the yellow question mark to view the On24 Help Centre. Now that we have that out of the way, I would like to hand over to Jose from Epic.
Thank you very much, Kerry. And I think I can say it now. We are live. It is 3 o'clock in the beautiful city of Noordwijk in the Netherlands, 20 kilometers south of Schiphol Airport. And I have the great opportunity of share a live 1 hour with two of the people in Europe that I look up to the most. Theodor Nielsen, CEO of Nil Technologies, and Oscar Fernandez, the Chief Technology Officer for the Fabulous pilot line. I would like to start this discussion with asking them about what their company does. Theodor Nielsen, what is Nil Technologies? What do you do?
Hey, Jose, and hey, everyone. Thank you for the introduction. In Nil Technology, we are working with applying nano-optics to the future of 3D sensing and imaging. So we're working with diffractive optics, meta-optics, also a bit of the microlens arrays and refractive optics in order to create the future of mobile sensing and sensing for other applications.
And we also have Oscar Fernandez from Fabulous. Fabulous sounds great, sounds fabulous. What do you do?
Oh, hello, Jose. Hello, everyone. So what we do in Fabulous, so Fabulous is the European pilot line for the manufacturing of freeform micro-optics. So freeform micro-optics is probably the next generation or today's generation of optical solutions for many applications. And we are creating a pilot line with the aim of establishing a one-stop shop in Europe for the manufacturing of freeform micro-optics for all kinds of applications. So from origination to UV printing, design, covering more or less all the aspects related to the freeform micro-optics.
Today, we are here to talk about cell phone lens manufacturing. And we really want to understand, with the companies in the room, but also with the audience, what challenges we may face and how this revolution of micro and nano optics that we are currently living can actually solve those challenges. We have a set of nice open discussion here. If anybody in the room has any question, comment, challenges, please share them with us. I would like this to be as interactive as possible. And if you are as excited as I am, get ready for something really truly special. Let's start the discussion. Let's start. Cell phones. Cell phones. I have an Apple iPhone 10 in my hand. When I see the future trend of cell phone lens manufacturing, I could see that size restrictions for cell phone camera lenses are actually becoming tighter. Actually, from our perspective, I see two ways in which designs are evolving to address these new challenges. On one hand, we have the freeform and the spherical lenses, and on the other hand, we have the meta surfaces and diffractive components. Would you agree with this? And what are, in your opinion, your trends and the opportunities that you see for your company? Theodor, take this first, and then we go to Oscar.
Well, first, thanks, Jose. I definitely agree on the initial thoughts here that there are two obvious choices to address the future of the. And now you're saying the bulky part of the lenses, so the cameras, to take pictures. I also think that in the near future, it is the aspherical lenses that will be dominating, simply because the trend is not to compromise on the image quality. When that is said, I think there's a very, very exciting future for meta optics and meta lenses, or as we call them here, meta optical elements. I think that, I mean, when you read some of the latest marketing material coming out in press releases, one can be led to think that a one surface meta lens will replace the entire optics and bulky systems that you have today. I think that will not be the case, at least not for any foreseeable future. But I think it's definitely possible within a reasonable amount of time that some of these 6P or 7P systems can be reduced and to have fewer refractive elements, and then replaced with one or two meta lenses, such that you will have a 4P1M system, for instance. And I think that's the trend it will go, and how it will be implemented. And there you will start saving some total track length. You will have more functionalities. So same performance, but a more advanced optical element system, so to say.
You know, for me, the problem with the mobile phones is that we make a lot of them. This is a very, very large volume. And even though we pay 1,000 euros for the whole thing, they are very highly limited in the price, in the cost of every component that goes on it. We are talking about high demands now on functionality and high demands on high resolution features in optics. How do you see this as an opportunity? Do you think that we have a problem here on high demands versus also high challenges on the cost?
No, so to say here with a bit of a Danish humor, you know, I like to say, you know, I like others to see problems, and for us, I think we see a lot of opportunities, especially for the high demand, to quality performance. When you're talking about meta lenses, translates into how accurate do you control each of these meta atoms, the precision, size, shape that makes out the meta lenses. And coming from a company here that has been working with e-beam and nanoimprint for almost 2 decades, I mean, we feel like fish in water here. So this is it's a nice challenge for us to work on. Yeah, so we are excited about it.
What I love here, you know, this is the beauty of the master. You make the master, and then you can use for replication. I want to go to Oscar from Fabulous. In the pilot line Fabulous, you have actually looked at different ways of making the micro optics. We talk about replication based on masters, but then you also talk about roll to sheet and even roll to roll. When you see about these two trends, on one hand having meta surfaces and the other one having free form wafer level micro optics, what's your take on this? And do you think that for penetrating the cell phone lens market, we have an opportunity or a big challenge for Europe in general?
I mean, with respect to comparing freeforms with meta sources, I cannot really talk because meta sources is not really my topic. What I see for the way at least Fabulous is built up is that mass manufacturing is of course an advantage for us in terms of reducing cost, because most of the cost is associated to the creation of the lenses, whereas the replication material and replication is expected to be a lot cheaper. So the bigger the market is, the more favorable is for UV imprinted micro lenses.
When it comes to the volume needed for the cell phone market, how do you see this market in general for Fabulous? Do we expect to set up new processes for other companies to transfer them, or do you dream, like I do, to do the production here in Europe?
Well, that'd be really great if we could actually keep the production here in Europe. This, of course, is I mean, it's a difficult question to answer now, but definitely, yes, it would be super great if we could keep the production of these highly added value components here in Europe.
I want to go back to the technical side, Oscar. You are the Chief Technology Officer of Fabulous, and I want to address the topic of the pros and cons of using fully refractive, or call it catadioptric designs versus the designs that include diffractive components. What do you think would drive a company towards one solution or the other?
Well, I think Theodore mentioned that in the previous question, is performance. So I guess they are not compromised on performance as we see the market going for better and better performance. So I think performance these days is what is going is going more or less for us for the freeform micro lenses. With respect to cost, I don't really know which one is more advantageous, but I guess performance-wise is our domain, because the 3D shapes that we can model as we wish. So performance levels are expected to get very high with the freeform micro optics.
And here it comes the opportunity, Theodore. Theodore from Nil Technologies. What I can see now is that we are trying to reduce also possible the amount of lenses that we can actually integrate in a mobile phone. I'm going to address this to you, but I'm also going to introduce one of the people in this debate. I would say the captain of the team today. We have in the room Sanjay Gangadhara, the CTO of the company that provides software for design that I love the most in the world, CMAX. Sanjay, thank you very much for being with us. This is your show.
Yeah, well, Jose, I appreciate it, and I appreciate you actually captaining this to the introduction. Of course, when things are live and things are at home, the technology always finds a way to conspire against you. And so I was having some technical difficulties getting on, but I appreciate it. I wanted to thank you. I wanted to thank Theodore and Oscar for joining us today in what I'm sure is going to continue to be just an interesting and exciting discussion about these technologies behind cell phone lens design and manufacture. And so, I know we were just getting to the topic of how do we potentially streamline designs? How do we potentially use more integrated designs as a part of the next generation of cell phone lens designs? And so, yeah, I'd love to hear a little bit more about that. What are the technologies that would allow us to take these bulky camera lenses that we're seeing in current cell phone designs and really start to streamline them and miniaturize the footprint as we move forward? Yeah, go ahead, Jose.
No, on that, I actually wanted to know the views of Theodore Nilsen, because on this, sure, we really have to see there is a chance that we can reduce the amount of lenses in the mobile phone. And we have seen a little bit of a trend of companies trying to provide integrated solutions. Is, in your opinion, something that we can address with either meta surfaces or with very complex designs that can actually manufacture in a simple way through replication?
Yes, Jose. Just before I answer, just for everyone who's on here, I see in the chat that there's a lot of people complaining about no video, and I think we are working on it on our side, on the technical side. So I believe for now they have to stick to our voices. But just a service announcement. No, I think clearly, a lot of amazing things and things can be made with aspherical, free form, stacking these together. It has been proven, it's out there. That's how people do it. That's how it's done today. When it comes down to manipulating the light through the lens system, our take on it is that it is actually easier to generate a desired phase function by diffractive optics or meta optics compared to an aspherical lens. The question is just the challenges of producing that diffractive optics or meta optics. And this is where this is where things are becoming exciting now, because the technology that we have here at NILD and others also have allow us to design these new exciting optical elements to give that functionality. And all of a sudden you can take aspherical lenses, and then also the lenses that are used to correct the errors from the first one, and just create one meta lens that does gives the supposed phase function to begin with. And and again, now looping back a bit to what I said before, having the right design tools, but also having access to the accurate control of the meta atoms, size, shape, and the materials. Mm-hmm. These things are now starting to become realizable. So I know here we have internal demonstrators here in NILD Technology, where we have demonstrated reduction of refractive lenses in the system with by using meta lenses. So results soon to come out, but we are doing it internally.
So it's interesting, Theodore. I've seen diffractive meta lenses as being, certainly the next. I mean, I don't want to say the holy grail, but certainly has been talked about. I think for cell phone lenses, for lots of different applications, in terms of imaging system design. Now, I think one of the challenges that I've run into, or I've heard about, is the color challenges, right? So when you're working with diffractive components, with metasurfaces, having a polychromatic system, and so again, when you're in a cell phone lens, of course, color quality can be just as important as as any characteristic. And I know, there's been some interesting work that's being done on polychromatic design of metasurfaces, things like that. How does that tie in? Has that been a key to advancing some of the technology that you're talking about, or are there other advances that you or have been making to try and address that challenge?
I agree. And to handle for instance, the whole entire visible spectrum is a completely different challenge than handling monochromatic solutions. And I would say that's also, we here in NILD Technology, we are focusing on monochromatic solutions as a starting point. So near infrared, and also looking into the SWIR band. And when this is set, you get all the learning points, and you get all your methodologies in place to start tackling the visible wavelengths. There's also a question about what material systems you're working on. So it's a different material system compared if you do near infrared to SWIR to the visible. So it's a good point. And I also believe that the future for sensing applications, where you need both an emitter and a receiver, are much more near than replacing the RGB camera.
Sure, and I want to maybe come back to that one a little bit later as well. But I'd be curious to bring Oscar now into the conversation, because I think, from my perspective, your solution really is thinking more about the aspherics, the micro optics. Do you see the benefits of that for really addressing this kind of full visible spectrum problem that I was addressing, or what benefit, I guess if you were to contrast to some of what Theodore was talking about, how do you see micro optics playing a role in reducing the footprint, or even potentially reducing the number of elements on a camera lens, while still addressing this issue of trying to capture the full visible spectrum?
Okay, so the color effects that we have when we use refractive structures is much less than for diffractive optics, and this can be also corrected via material tuning, which is something that also Fabulous is doing. So color aberration can be sort of corrected not only by design but also by material tuning. And indeed, freeforms are known for allowing reduction, for allowing actually both an increase in performance and also a reduction in the number of lenses. Not only the going microstructures will reduce the footprint, but also being able to play with the shape and adapt and really do freeform shapes, where the curvature is as it needs to be, depending on the application, that could also reduce the number of components. And don't forget that in Fabulous, we're also targeting double-sided replication, so we can have profiles on the top and on the bottom, which will multiply the capabilities by quite a factor.
Okay. Well, that I think gets then to kind of one of the next topics that I wanted to talk about is then manufacturability of these systems, right? I mean, the decision in some ways to go between, either a kind of a freeform or a micro-optic solution, or maybe perhaps the metal end solution that Theodore was talking about, may, in many cases, come down to the ability to manufacture. So, with Fabulous, of course, this is one of the things you're trying to address with the pilot line. I'm sorry, I know you and Jose were talking perhaps a bit about this while I was getting connected to the call, but I'd be curious, I mean, do you see significant advantages in terms of manufacturability of refractive designs versus diffractive or metasurface type systems?
Well, from my point of view, as I said before, I am not much in the metasurface technology, so I don't really know what are the drawbacks in manufacturability. What I can say from the freeform point of view is that there are emerging technologies. I mean, the classic technologies, they've been improved towards freeforms. I'm talking about mainly diamond micromachining, for example, that has been is continuously being advanced towards the manufacturability of freeforms. But also new ones like two-photon absorption, for example, which is becoming or is being improved continuously with, I don't know, for example, the release of this nanoscribe grayscale two-photon absorption system that can print very nicely over probably 50 times less time than before. So all these advantages are really an asset to the manufacturability. And these are not the only ones. There are more. Femtosecond laser ablation, femtosecond laser polishing. There are new technologies that are being continuously improving to improve the manufacturability of these freeform microlenses.
Okay, interesting. And Theodore, if I can maybe bring you in for the converse perspective in terms of manufacturability, so certainly I think you were alluding in some cases to the idea that with metasurfaces you have great flexibility to design the phase profile and the response that you need. But of course, then actually manufacturing that is the challenge. Can you talk a bit about, your company, of course, is addressing that, but what are some of the trends or what are some of the technologies that have helped really aid that over the last few years?
I mean, to generate meta lenses and how people typically are, for instance, prototyping it, that's by e-beam lithography. And then from there, when you want to scale it up, there are in principle two routes. I guess we have a big audience today, so they can probably think of many more. But I would say, from my perspective, there are two routes. You can either go classical deep UV immersion deep UV lithography, or you can go with nano imprint. My company is NIL Technology, so I guess you can guess where I'm putting my box. So I believe nano imprint is the way forward. We have full flexibility of the masters that we use to print. We can take the full resolution that we have with e-beam, whatever small changes to the design, we just write it, realize the master, and print it, and we get those structures in. While in one of the disadvantages of deep UV is that it is basically designed for semiconductor, right? So it's more lines that you're now optimizing on to get other type of structures. So, but there are probably many religions in this area. I know we have some amazing results here, and believe that we have a strong way of mass producing this moving forward. So I feel relatively comfortable, but of course I have a lot of insight to this on the MP of it. I think the two big challenges moving forward is assembly, or how to put the meta lenses, how to integrate that into the system, how to fit that in with the refractive lenses. That's one. And then another key topic is also the efficiency. So how much light passes through the system, which is also, of course, a very interesting topic to have a solution on.
Oh, sure. Sure, and it will be interesting on the. Well, I'd be actually to bring in our fourth member, Jose. I'd be curious to see, given your broader view of what you're seeing from EPIC, do you see any trends emerging in terms of one refractive versus diffractive solutions here, as with respect to ease of manufacture or manufacturability? Are you seeing more focus in one area or another from your viewpoint at EPIC?
Thank you very much, Sanjay. Actually, the biggest push that we have seen, is to add functionality to the cameras of the mobile phone. And on that, I would like to revisit some points. Sanjay, between the lines, you talk about the visible spectrum, collecting as much light as possible from the visible spectrum. And I think the light is a lot broader than the visible spectrum, and there is a lot of interest here on going into other areas, especially for environmental monitoring, for adding sensing technologies, for adding beyond knowledge to the mobile phones. And on this, I would like maybe to also ask the other people in the room, do you see a need or is there a chance to use these meta surfaces and to use these nano-imprinted lithography-based micro-optics for adding functionality beyond imaging on mobile phones?
One word, yes. So let me grab it here, if it's okay. Of course, I mean, this is the infrared sensing area is extremely exciting, and also I think a much sooner market or application for the meta optics to be adapted into creating there are both the front facing and the world facing sensing 3D system in the mobile phones that is driving here. There are the LiDAR systems that are now starting to become integrated into the mobile phones, and of course we then have the spillover and the synergy to a big extent into other applications areas such as automotive, which of course not the topic of today, but there's a lot of synergies here in working both in the near infrared and SWIR band.
For me, the beauty is that with these micro-optics, we are actually enabling, I'm sorry to call them micro-optics because Nil Technologies also developed nano-optics, but at the end of the day, we call about high-resolution optical elements. What I have seen is that we can do fantastic beam shaping together with beam steering, and that is, in my opinion, what is the biggest revolution that we see by bringing optics into the consumer. You said very well that now we have Apple products with LiDAR integrated already for more than a year, and in my opinion, there is another opportunity here, a very big opportunity. Most of these devices actually do have lighting. They do have actually a lighting for you to see around. And I believe, and I think that another trend is to actually have knowledge and know-how that we have for beam steering to give functionality to that lighting that the mobile phone can provide. Do you see perhaps this as an opportunity? And on that, there is huge applications, because Theodore mentioned automotive. The light carpet for two of the best automotive companies, the light carpet, the micro-optics for the light carpet are manufactured here in Europe. So we do have great know-how on this. Is there an opportunity to do some beam shaping, beam steering on lighting for mobile phones? I wonder if perhaps Oscar can take this.
Yeah, I can take that one. Yes, I actually see, I mean, what I see myself, I don't know if you would agree, but mobiles are used now as for many people to record videos and pictures and upload pictures on the internet, etc. So, I mean, the phones are not just equipment to take pictures, but they are becoming kind of a professional tool for Instagrammers and influencers and the like. So having a good illumination is essential for this video and photo. And I guess at the moment, the flashes on the mobiles are quite primitive. I would say. So there's a lot to do in terms of illuminating.
Now, it's interesting because so I think Jose talked about other applications with respect to lighting. Because you're illuminating a scene, is there structured lighting that you need to have out of that? Another, I think, interesting application that, of course, has been much in the news with respect to mobile phones is actually using the optics and the photonics on the phone for healthcare, for diagnostics, right? So there are, for example, CRISPR-based scans that you can do to actually detect COVID using your cell phone, things of that nature. Other, scanning or wearable type of technologies that are associated almost to the mobile phone as well. Are these things that actually impact? How do you see, or do you see that the design of the different optics and photonic systems are impacted by this need for integration of the kind of the multifaceted nature of what we're doing with our smartphones?
Okay, I can give it a shot. I mean, the way I see it is that for mobile cameras, and I also said it before, maybe it was when you were not here, Sanjay,
Yes.
Image quality is a strongly competitive parameter in this market space. So I have a hard time imagining any mobile vendor starting to compromise image quality in order to make your phone multi-purpose for other things. But I do on the other, but I also think it's very, very good cameras that you have in the mobile phones anyway. So I'm more seeing that there are people or there are applications that will tap into the infrastructure and to the fact that we are all running around with a computer and a sensor and a camera and whatever we can call it in our pocket. And then there could be applications out there. I don't want to speculate about that could motivate a separate socket. I mean, that could be a thing, but I don't think that the exact camera will be modified to less performance in order to serve other purposes. But I mean, maybe others have different opinions on that.
Well, no, I would be interested. I would agree. I'm curious to see. Yeah, I mean, if Oscar or Jose, if you have any thoughts on that as well. But in the meantime, I did want to say there are some questions coming in from the Q&A that I thought would be interesting. And so one question for you, Jose, comes from Thomas Abo at Kalido Technology that asks if do you believe that meta lenses will be able to compete on image quality with the current 6 lens systems that you see in camera phones, and is that something that you see happening within the next few years?
Not with the next few years. I had to be quite realistic on this because we are talking about if we are talking about functionality. If we talk about functionality, they compete already today and they competed already for the last decade. But we are not talking about functionality here. We are talking about manufacturability and market penetration. And on this, I do believe that the best positioned company one of the best positioned companies in the world is actually with us, is Need Technologies to answer it. I want to tell that in the next 5 years, what we have to do is a lot of education and a lot of myth decay, because there's a big myth on what kind of technologies can actually go into the semiconductor market and even beyond that into the consumer market. I think we need to decay that myth, because if we penetrate that, in terms of functionality, there is absolutely no competition. It's already surpassed. But in terms of market penetration, we do have a challenge here. Theodor Nielsen, what do you think, and to what extent do you disagree with me?
No, I do agree. And I think it's also a tricky question. Maybe the hint to give an as easy answer is just to say, because the question was within a few years, and I think no, not within a few years, but and then I think then from there it's a grayscale kind of thing, because meta lenses, I think, on a 4+ maybe 5 year time horizon definitely can go in and replace some of the refractive lenses, but not all of them. I think we have a long way to go until we see an RGB camera in a mobile phone that is 100% meta, if it ever will happen, who knows? There's still some bottlenecks to overcome for sure.
Mm-hmm.
That's how I see it. That's how I see it.
Sure. No, I think that's fair. And so in the meantime, of course, micro optics I think are important, and it's interesting because Theodore, you mentioned, and this is maybe a topic where a question that came up that I'd kind of be curious, because in many of these systems, it's not just the meta optics, it's not just the refractive optics, but it's an assembly that contains all of, some composite of these components, right? And so I'd be curious, in terms of, there's the manufacture of that, how do you manufacture, assemble those? But, I also am curious, from my seat to understand, how do you think about simulation of those systems as well, right? How are you thinking about how, design and simulation to make sure that you can actually have accurate and robust prototypes as you're coming to market? I'd be curious to get your perspective, and then also to hear from Oscar about that on that same question as well.
No, I think it's the most critical part, actually seen from my chair. I think I will let all the people listening in, you can trust us on solving those, creating the meta lenses. I got you covered. Don't worry.
Uh-huh.
But putting it together, assembling it, that is where I see one of the big bottlenecks and challenges that has to be addressed, especially, it becomes more and more relevant the more complicated optical path you're putting together, and how many polychromatic versus monochromatic. And their simulation is going to be a very, very important tool for us. So hurry up, Sanjay, please.
Well, we're working.
If I can comment on that,
yes,
Sanjay,
ahead,
I do
Absolutely.
believe that there is a problem here in the supply chain. So we do have great manufacturing. We have, thanks to you, Sanjay, we have great design tools. But what we do not have in this community is enough IP companies that provide building blocks already tested and manufactured, IP companies that we do have in the semiconductor business, that we do have even in photonics, in the photonic integrated circuit business, in which you can actually buy a design for a modulator already tested at the foundry level, but we do not have in the micro optics world. And most of the time, the customer needs to start the design from scratch, needs to do the ray tracing thanks to the great tools of Seymax, but needs to start from scratch. I would like to have a library of components in which I could purchase a certain design and have it manufactured by Fabulous or by Near Technologies. Is that a dream, or Sanjay, do you think that could become a reality?
No, I absolutely. Well, I think to me, the reality, is there. I think it's absolutely a reality that we can think about having, just as we think about it for any kind of components within larger scale macroscopic optical system. Right now, we talk about libraries of LED sources. We talk about libraries of materials that are being used to characterize, components inside of systems, and just moving down the chain. I think, I don't see. I think for me, it's the data, right? Where are we getting the data, and do we have enough scalability to produce enough data to make it so click and drag that I can shop from a cart, almost as you're talking about.
It is not obvious to make a design. Yeah. It is not obvious to make a design for an optical element. It is not obvious. It's actually quite a tedious and complicated work.
Sure.
And the optics companies in the world are actually investing on making their own design teams, because instead of waiting for the design to come from the customer, they are helping the customer doing that design. And that's a trend that is slowing down, in my opinion, is slowing down innovation. But I would like to see if this view that I have is aligned with the other people in the room. What do you think, Oscar? Is that a challenge that we have, that we need to train our customers on designing and even sometimes designing for them?
Well, yes. Designing is, and simulation is still something that can increase the lead time quite substantially. And not only because of the design, but also, which is as important as this, which is design for manufacturing. So you can have a design which looks ideal in your simulations, then you go and try to make it, and it's not possible. And this distance between the designers or the companies that do the design and then those who manufacture, who have to manufacture these solutions, we see quite a step in there still. And this is something that we're also trying to tackle in the Fabulous by doing some design for manufacturing in the way that you can attune your design to known manufacturability constraints of the technologies that we have. So everything that is designed for manufacturing.
But so when you're talking, go ahead, Theodore.
Yeah, I was just,
let
me add to this because I think, Oscar, this is, I mean, Jose, when you asked your question, I was thinking, I see the opposite. So I would say that the path, Oscar, that you are just outlining here, I believe strongly in this. And this is exactly what we have done in NIL Technology. We do everything from design to prototyping to setting up the MP process. And we take in all the boundary conditions and have a very fast loop there. And that leads me to looking at this from a complete opposite perspective, Jose, and say, because we are also doing the design, but we are solving the problem that our clients wants to have, we are faster. We are faster than it because it's in-house. So that's my perspective on it.
Yeah, I think, and perhaps, Jose, if I can interject, I think while it certainly allows to get to market faster, does it somehow gate the scalability in the sense that, now to get those kinds of designs, it's really, NIL technologies, it's Fabulous that needs to work to really produce the robust design, and one of the things that we try and do at ZMax through simulation is to some extent we're trying to enable more scalable design, right? So anyone can design in some sense, right? It makes me think, just to throw in one of my kids' favorites movies is Ratatouille, where one of the great lines there is "anyone can cook," right? So I keep thinking anyone can design, and so we do try and allow for that scalability of being able to come into the tools and create the systems that you need. And so how do we bridge that gap where at the moment it seems maybe Jose is pushing that you need some level of domain expertise to really be successful in designing for manufacturing? How do we maybe bring that down to the customers, to the clients, to the people so that they have access and they have the knowledge to be able to be more successful without relying on kind of the insights that someone like yourself or Oscar are providing?
One of the best tools that I like from ZMax side is that it's quite easy to make a parametric-based design, which can be actually quite altered by modifying some parameters. There is a lot of reinventing the wheel when we are making designs from scratch for new products. And I do love that Theodor Nielsen increases the speed to commercialization by helping the customer design, and I really favor that. But I wonder if there would be room for more cooperation at design level between all the players. And I think for that we need a platform. We have implemented that. It's not new. Platforms like this exist in semiconductors. Platforms like this exist in silicon photonics. I wonder if there is a room for having a platform like that for designers to collaborate in an open way to increase the soundness of this fantastic micro-optic technology.
I mean, I absolutely think that could be of value, but that's again where I'd be curious to see what others in the room think as well. Yeah.
Theodore, when you had to design, you say that, of course, you increase the speed by helping your customers with designs. But to what extent it is always starting from scratch? Because, of course, every customer has very, very defined product with very well-defined IP that they want to keep. So isn't that a challenge to always reinventing the wheel for every project?
I'm not sure we're reinventing the wheel. I mean, a diffuser is a diffuser. You get the specs. It's kind of the same. I mean, there can be variations to the specifications, but it's not reinventing the wheel. It is a fan-out grading. It's the same. So in that sense, I mean, you are optimizing parameters. You might have different XYZ restrictions. You might have different beam profiles, etc. And I think this is something where I think, okay, conceptually one can think of it could be nice to have open forums, but I'm not sure I know that many, me included, who are willing to share. And also the designs here, but there's also another thing. The designs, at least when you start talking about diffractive optics and meta optics, the designs are tightly bound. I mean, the design and how that is put together on the nanometer level in the structures is tightly bound by. I mean, there's a tight relation between design and what you can achieve with your MP process, and this is where it becomes, in my point of view, a very strong thing from our side, that we know exactly how much we can squeeze the boundary conditions in the design and what we can realize, and then in the real world, and then also we have the capability to do the reverse design. So when we have realized something the first time, we can at one hand we can measure the optical performance, but we can also measure the geometry. And then we can put the geometry back into the simulation tool and say, what should we get out? And there we have, of course, there we always have one-to-one correlation. And then we can start manipulating on the software. I mean, outside the lab, on where is it that we have to optimize our MP process to get the right performance out. And this brings us down to that we can realize new designs on spec with a very, very few iterations. And then we can go and validate it very, very quickly in the lab. So, yeah, and so to start open up design parameters, that means you also start opening up your boundary conditions and the parameters in your manufacturing, and it just becomes sensitive.
Okay, that's interesting. You touched on something there towards the end of the conversation that made me think. I mean, to some extent, for you, the best solution is almost sounds to be a solution where the design and the manufacturing is being done really in the same place. Would you agree? I mean, that you're not necessarily decoupling those activities, where the design is being done by one vendor, manufacturing is being done at a different vendor.
Of course, that can be done. I mean, there's nothing wrong with that. Sure. I'm just saying, I believe that we can act even faster. And create even better solutions when you have freedom to solve the real problem and not being limited by other people's maybe true or not so true thought of boundary conditions.
Oh, sure. No, sure. Oscar, would you, your perspective seems to be similar, I think, in that, when we've talked in the past, you've talked a lot about helping your clients, your customers in the design for manufacture and actually helping facilitate these designs. Do you see that same perspective that Theodore is presenting here, that really being able to have that design in-house while as a part of the manufacturing process is really what drives to the best solutions?
Well, at the moment, yes. For future, I think our dream would be to sort of get a design confronted with the manufacturing limitations that we know and we have quantified continuously. So we monitor continuously as the manufacturing technologies are improved. And then say, well, this is not manufacturable because of these parts are not possible. But more importantly, to be able to tune or to adjust these parts, these problematic parts, so that they can be manufactured and then predict what is the degradation in performance by just relaxing on these parts of the design. And that way, we could have a design that we know can be done and we know how it will perform. So this is what we are trying to build up at the moment. Because, as a pilot line, we are expecting orders or customers in many different applications. And design is oftentimes very specific to the application. So it's not the same if you're doing something for automotive or you're doing some imaging or projections. So we would like to give the customer the flexibility to do their own designs, and then having the possibility to check realistically whether their designs can be manufactured, or if not, how they need to tune their designs to meet the pilot line requirements or limitations, and then know how much the performance is expected to be impacted. And this will give them a quick way to decide, okay, we go for it, or no, it's not possible for us, or it's not acceptable, the performance.
I did want to turn to there was an interesting question that came up, and it is also making me think about other ideas that may be outside of the box of what we're talking about. So there's a question here from Darwin Hu about what the role of liquid lenses may be as we think about trying to reduce the footprint on cell phone lenses, but perhaps other consumer electronic or devices. Have either of you, and maybe Theodore, I'll turn to you first. Have either of you seen the use of liquid lenses or electro-optic lenses coupled to refractive components, coupled to metal surfaces as being a hybrid solution that's provided any benefit?
I have not seen the combination. I think it's only a few weeks ago there was an announcement, right, that one of the big Chinese mobile phone companies had implemented liquid lenses in there. So that is definitely, at least there's one case out there where it's being implemented, and I can only imagine that exciting things can be happened if you start combining these things. But it's not something that we have looked into in detail yet.
Okay. And then for Oscar, from your perspective, is that, I don't know how that would play a role in terms of your pilot line, but is that something that you've seen or had any visibility into yourself?
No, same here. Same answer here. We have not yet considered those things in Fabulous.
Mm-hmm. So, okay. It makes me, as I was saying, it makes me think about, other areas of technology that can be involved that maybe we haven't thought about, because the other kind of advantage that may come to help reduce footprint or improve performance here is computer vision. And I'm wondering a little bit, we tend to think about these more for larger scale systems, being able to use computer vision algorithms, for example, on, in heads-up displays or mixed reality headsets. But I wonder to what extent, as I think as you were talking about earlier, Theodore, basically the smartphone has just become a computer in your pocket. I wonder to what extent, computer vision algorithms also can influence or even decide, a bit how we decide to design and manufacture some of these systems. And so again, I wonder, is this something that you've seen or have any visibility to, or is this still something that's far afield from your perspective?
So it's not something where I'm maybe the strongest to comment on this. I know that we are, to have computer, what did you say, machine, we are using machine learning and AI type of algorithms in our work. That's clear. I think there's a trend towards that, but that's very deep inside the machine room. I'm not sure if that is what you really asked.
Well, certainly I think that's part of it, but part of it is again, when we think about image quality being one of the main driver, image quality, of course, can be driven by the optics, by the hardware, but it can also be driven, you can enhance image quality, software programmatically. And so just that combination could potentially drive a new type of design that neither solution could bring to market individually, right?
Okay, I can only speculate here and imagine, and I think it's obvious to think yes, I definitely think there's a route there, but it's not something that I have that deep knowledge into, that side of it.
Yeah, no, that's...
So Sanjay, sorry to interrupt, but we do only have 5 more minutes. So I don't know if we want to answer maybe 2 more questions before we wrap up for today.
Yeah, no, I think that would be great. I mean, I'm gonna pick a question that may not be able to fit in 5 minutes, but I do think it's an important one for this audience. So this is a question that comes. It says, in your opinion, how will the European market bridge the gap with Asian innovation and manufacturing in terms of cell phone lens manufacturing capability? And I think this is, for me, an interesting one as well. Jose, I think, touched upon this a little bit earlier in terms of bringing more of that IP and that knowledge to Europe. What do you see as the next steps, and especially in light of maybe, what's happening in Asia with respect to cell phone manufacturing?
I think we're actually doing it right. I think the ideas that we were brought here today by both Fabulous and Neil Technologies are the right way. So we have technologies, for example, what Oscar said about doing the freeforms on both sides of the lenses are very good at research side, and to take them to production, you need to start by doing the pilot production. And on that, I do believe that we do have the right place in Europe. But I also have a dream. If we are going to take this to production as well, why not in Europe? In Europe right now, we are talking about this 2 nanometer foundry for semiconductors. And people are saying, why Europe should have a 2 nanometer foundry? I mean, why not? We had the best lithography machines. We had the best deposition machines. So why not? And the same thing here. We had the best micro-optics right now in the world, not only with Neil, but also companies doing 2-photon polymerization, companies doing deep UV, companies doing roll-to-roll, roll-to-sheet. We have the best one here. So the pilot is already today possible, and commercial products are already being offered by the companies. Future is production, large-scale production here in Europe.
Yeah.
So I do. Oh, sorry, Sanjay.
No, go ahead.
I was just going to say we are rapidly running out of time. So I don't know if you wanted just to finish off, and then I'll wrap up.
No, that would be fair. Thank you, Carrie. I appreciate it. I appreciate everyone's time today. Again, I apologize sincerely for my technical difficulties at the early part of the session, but thank you to Theodore, Oscar, Jose, as always, for a wonderful, insightful conversation. I really enjoyed the time. I look forward to continuing to partner with all of you as we evolve these technologies and these solutions. And it's, thank you again.
Perfect. So that is all that we have time for today, I'm afraid. Thank you, Jose, Sanjay, Theodore, and Oscar for your time. And thank you so much to everyone that is attending. If you do have any further questions for our panelists about what you've heard here today, we do encourage you to submit your questions, and we will be sure to follow up accordingly. And for further information, please reach out to the Zemax team. You can do that with emailing events@zemax.com. And I hope that everyone has a wonderful day, and thank you once again.
Thank you.
Thank you, Carrie.
Thank you very much.